Assalamu alaikum warahmatullahi wabarakatuh. Students, today we are going to learn 15.2. The last video we learned 15.1, what is pressure. Here we are going to learn about hydrostatic, right? In this situation, how we can express pressure, right? That is what we are going to discuss today in this lesson, right? In the hydrostatic pressure, I told you that the term we are using for fluids, right? Two states can be considered as fluids in the matter, right? The one is liquid and the other one is gas, right? We can consider these two as fluids, right? In this situation, we just take this first. After that, we are going to discuss about this, because there is a special character for gas when it express or when it give pressure, right? For the liquid, first if we consider the liquid pressure, the common equation, right? You know, the pressure is equal to perpendicular force divided by the surface area, or the force, the area of the force exerted, right? This is the equation for the pressure in all the places where we are talking about the pressure, right? If you keep this, if you hold on this equation, then if you go anywhere, you can handle the pressure very easily, right? The pressure is equal to the force exerted, or the perpendicular force exerted, divided by the surface area of the force. Okay, right? Now we'll consider the liquid. A liquid. You consider this as a liquid. Here we have liquid, right? For the liquid, in this place and this place, if you consider these three places, A, B and C, at the A, if you consider the pressure as PA, at the B is PB, at the C, PC, right? For the PA, at this point, if you keep your head here, if you keep your head here, right, you are going to feel the pressure, right, which has been given by a water column of this amount. At this point, the water column of this amount. At this point, a water column of this amount. Then more water column means more weight of water is going to give a pressure on this place. Lesser than this amount of water column is going to give a pressure on this place, right? Here lesser than this, right? Therefore, without understanding the phenomena behind the liquid pressure, you can easily say the pressure at the place C should be higher than the B, should be higher than the A, right? PC is more than PB, PB is more than PA, right? Using this idea, we are going to find, right, how much, what is the value, right, what is the value in the number, what is the quantity, right, that is exerting, the pressure exerting at this point. Okay, right? We'll construct a small idea. You think about a small water column at this point. A small water column, which will take it as a shape of barrel, right? Small water column with a spherical, with a circular cross area, right? We'll take the area as A. The considered water column height, if it is H, right? Now I am saying the density of the water is rho. right? You know the density from your grade 9, I think, right? Density is equal to mass divided by volume. Keep this equation with you, right, to construct this idea. I am saying this density as rho. The density as rho, right? Mass of this liquid column, we'll take it as m, right? The volume, right? I am saying it as v, right? Now I am going to find the pressure. You know the common equation for pressure is what? The pressure is equal to force divided by the area, right? Force at this point, at this bottom of this water column, right? What is the force exerted? The weight of this water column, right? Weight of the water, not the mass. Weight of the water column. What is the weight of the water column? Mass into gravitational acceleration. Is it correct or wrong? Yes, right? Divided by the cross area A. That is the area where this water column going to give a pressure. I am considering a amount of area. Now for the m, I can say here the rho is equal to m divided by v. Therefore I can say the m is equal to rho into v. I am substituting this rho into v instead of this m. Okay, then rho into v into g divided by a is going to be the equation or the next step, right? For the v, for this v, I am going to say the v of this, right? You know the volume of a barrel, right? Volume of a drum is going to be the cross area into the height, right? The volume is going to be equal to cross area into height, right? Then I can substitute this a into h instead of this v, right? If I continue further, then I can write like this: rho into a into h into g divided by a. That is going to be equal to the pressure exerted in this place. If I cut this a and a, right, then the pressure of liquid column is going to be equal to h into rho into g. Okay, right? Then this is the equation that we are using to find the liquid pressure. Look at this. The liquid pressure is not dependent on the surface area or the cross area, right? In anywhere, if you want to find the liquid pressure inside the liquid, right, you should know these three terms. What are the three terms? H, the height of the liquid column. Rho, the density of the liquid. G is going to be the gravitational acceleration, right? Then this is the equation that we are using. Now consider this A, B, C points. For this liquid, rho is constant. At the point A, the same liquid is there in the B as well, right? The same liquid there in the C as well, right? The same liquid means same density, right? In a liquid, we can't differentiate the density. If you have given a liquid, right, inside that liquid, we always consider the mass has been distributed uniformly. Therefore, the density is going to be equal in all the places. Then the density here is equal to density here is equal to density here. Then the density is equal for these all. I am going to find PA and PB and PC. PA is equal to, right, if the height here is HA and the height here is HB, if the height here is HC, right, the height HA into rho into gravitational acceleration. The height HB into rho into gravitational acceleration. The height HC into rho into gravitational acceleration. Now look at this. Rho is constant, is equal for all. Gravitational acceleration is equal on the surface of Earth. Right? In anywhere, if you go on the surface of Earth, right, the G is going to be equal. Right? Therefore, the G is equal in 3 equations. What is the different value? Which is vary? H, the height. Right? Here the height is increasing. Therefore, the multiplication of this is going to be the most. The second one is this. The third one is this. That's why I said to you, the PC is more than PB is more than PA. Right? Then, if you consider the liquid pressure, this is the equation to find the liquid pressure or the hydrostatic pressure. Right? The second thing that you should know in this 15.2, right, there are some unique characters of liquid pressure. Right? This is very important and this should be believed by you. Right? This is a basic belief. Right? Like Iman Kolla Vendi Amsam. Right? Iman Kolla Vendi Amsam in the liquid pressure. Okay? Right? Keep this in your mind all the time. This is very important in the liquid pressure or when we are considering the hydrostatic pressure. The first thing, inside the liquid, right, with the depth, with the height of the liquid column, with the depth, the pressure get increased. With the depth, if you go inside, if the depth is increasing, the pressure is going to get increased. First thing. The second thing, in if you consider a point inside the liquid, right, in all the directions, the pressure is going to be exerted. Not in one direction, only in this direction or only in this direction, no. In all the direction, the pressure is going to be exerted, right? You have to add the another point to the second point is the exerted value of the pressure is going to be equal. If you consider a point inside the liquid, in all the directions, the pressure is going to be exerted, right? The value exerted by the pressure, the liquid column in all the direction, right? It's equal. If you keep your head like this or like this or like this or like this or like this, no problem. The pressure exerted on your head is going to be equal in all the directions. The second very important point. The third point, if you consider a horizontal level inside a liquid, not in different liquids, right? Inside a liquid, right? Think about the H. At this point A, B, C, if A, B and C are the points here, right? What is going to be happen? The rho is equal for all, G equal for all, H also equal for all, right? Therefore, PA is equal to PB is equal to PC. Then if you consider a horizontal level or horizontal plane, right? And if you consider the pressure at that horizontal plane in in anywhere, right? The pressure is going to be equal in all the places, right? That is a very important third point. Keep this in your mind, right? There are some activities given in your book to illustrate these 3 points. The first activity, right? Look at your book. First activity, there are some holes inside a tank, right? The water that has been reached horizontally are going to get deeper, right? Here less pressure for this liquid column, right? Therefore less displacement. More pressure, most pressure, most displacement can be seen. Therefore we can say with the depth the pressure getting increased. The second thing, if you take some water inside a bag, right, and with a bag with a holes, right, if you press it in all the directions, the water is going to come out, right? Then if you go inside the liquid, and there are some measurements, there are some instruments to measure the liquid pressure, right? If you keep the instrument somewhere here in this direction, the pressure is going to be equal to in this direction and this direction and this direction, all the directions, right? That can be seen using those instruments, right? The third point, it's given there. Look at that. In a same horizontal plane, in the same horizontal line, if you make some hole and if you fill the liquid, the vessel, right, the water which comes out is going to show you the same displacement of the movement of the water, right? Therefore, this is the very basic phenomena and the very basic idea or the very basic knowledge about the liquid pressure, right? Then the hydrostatic pressure is this much, right? We'll continue 15.3 in the next video. Jazakumullah.